what is the nice thing about this method? That it doesn't matter how far the camera is, even if it's closer, this marker is going to give a reference point for the size. And we can put also multiple objects. We have 2.2 centimeters and 6.2. Hi there, my name is Sergio and I help companies, students and freelancers to easily and efficiently build visual recognition projects. We're going to see today the easiest implementation possible of a project which measures in size each object. Let's say, for example, that we have this USB pen and we want that our program will automatically say this USB pen is, for example, 5 centimeters wide. This type of project is generally a complex operation because it will require some calibration of the camera, because if you put the object close to the camera, this has a specific size. If you put the object farther because of the perspective, this looks much smaller, but still it has the same size. So how can we solve easily this problem? In order to solve this, I got an idea to use what is an Aruco marker. If you don't know what this is, it's not a problem. We will see that later on the video, but this is a standard which is used in virtual reality, which we will use as a reference point, which will give us the size of the object. Doesn't matter how far the camera is and where the object is positioned. So we're going to start first to detect the object on the space. Once we have the object, we can check the size, the pixels area that is taken on the frame. Once we have that, with the marker, we're going to make the calibrations that we know the size of the object, whether it is centimeters, inches, or the size, the measurement size that you use in your country. So if you're ready, let's start. Now, in order to proceed, you need to make sure that you have Opencv contrib Python library. If you don't have that, this is the way to install it. You go on the terminal. So we open the terminal. So whether you have Windows, Linux, or Mac, it works the same. Once you open the terminal, you type pip install opencv-contrib-python. Just to make a clarification, if you have just Opencv Python, it's not the same as Opencv contrib Python. Opencv contrib has some extra libraries that are not on the official release of Opencv, which we need today. If you have Opencv only, you're going to get some errors. So I want to be clear about this. If some library is missing, it's because you don't have this one. So once you do this, you press enter and you can install this one. I'm not going to do that because I already have Opencv contrib. And now, once you have this, we can proceed by creating our script. The first step that we have to make is to, first of all, let's load the image or the camera. We'll start by loading an image, which I have right here, phone.jpg, so that we will work first with an image. Once we are confident with the image, then we will switch to the video camera so that we can detect the size of the object in real time. I highly recommend that you download the same images that I have so that you can follow along with what I am doing. To download the images and all the files that you see right here, you can download for free. It's the link below in the description, and there will be on the blog post some links to download the source code. Now we can finally start. First of all, let's import cv2, which is opencv. Then we're going to load the image. img equals cv2.imread. And now we need to put the path of the image and it's phone.jpg. How do we make sure that this is loaded correctly? We're going to show it. If we don't see it, it means that we have to change something. Im show. What do we want to show? Let's show the image, so title image or whatever you want, and then we want to show this one, emg. And then cv2.wait key 0 to keep the image on hold open. And now we can run this one. We see the image, so it means that we're loading the image correctly. Now, the first step that I told you about detecting the size of an object will be, of course, detecting the object. And there are many different methods to detect the objects. Some with basic Opencv image processing operations like this one, which we can do because there is a white background, homogeneous background, and there is a black object, so it's easy to detect. Or more advanced object detection methods using deep learning. I'm not going into details about this one. If you want to know more about object detection at a professional level and to implement on your object, I have a full course that you can check on my website, pysource.com. Now, to make this simple, I have created a file which is objectdetector.py, so you need to download and import that, which is going to detect objects on a homogeneous background. So we're going to import object detector. Actually, from object detector, we're going to import everything. And now we're going to load the detector. So right here, load object detector equals homogeneous background detector, homogeneous BG detector. So this one is the file that you have to download, and you have to put on the same folder where your main Python file is. So this is the folder I have, the main file where I am writing this, and then the object detector.py that you need to download. Once we have this, we can detect our phone. And we will do, first of all, let's print detector. So what do we get from detector? Object detector, still we don't get anything. So yeah, there is something that I forgot to put. So once we load the object detector, we need to use it to detect the objects on the image. So contours equals detector dot detect objects. Where do we want to detect the objects? We want to detect the objects on EMG, right here. Once we detect this, let's print contour, and let's see what we get. We have also the mask, and then later I'm going to hide this to you so you don't need to see this. But what we get right here is that we get all the boundaries of this object. So these are all the coordinates surrounding the objects. To make sure that we have correctly these coordinates, I'm going to show what you get when we draw them. So using this, let's draw a polygon, use these coordinates. Draw object boundaries for CNT in contour. So if we have multiple objects, of course, these we'll have multiple coordinates. So I'm going to loop through each single object that we have right here. So I print CNT, and let's run this one to make sure, okay, that everything is correct. We're going to take these coordinates. Now we will draw the coordinates on the screen to see what we are really getting from them. And so CNT, let's do cv2.polylines. Where do we want to draw the polygon? We want to draw the polygon on EMG. Now here we need to define the points, and the points we need to put them into brackets. This is how it works, the polylines function. And what do we want to draw? We want to draw these points that I was printing before, CNT. Now, is the polygon closed? And here we need to say true because we want a closed polygon. Now let's choose the color. I'm going to make this blue. 255, which is the blue, so from 0 to 255 we give maximum of the blue, 0 of the green, 0 of the red, and let's make thickness 2 so that we can clearly see the line of the polygon. And now we can run this one. As you see here, we are correctly detecting the boundaries of the phone. Once we have the boundaries, of course, we can later check the size, the height, and the width. Here things will get a bit more complex. Here we have a lot of coordinates, and this is not a specific rectangular object. Here it has a small curve which will make us hard to detect to detect the size, because if we had only 4 points, a rectangle, it will be easy to detect. We will take the longest one will be the width, and the shortest one will be the height, for example. But here we have a huge amount of points, which are going to make this operation complex for us. Luckily, in Opencv, there is a function which is going to give us a bounding rectangle right from these points. And we can extract that this way. Okay, draw polygon right here. Get rect cv2.rect cv2.mean area rect is going to give us the rectangle. Where do we want to get the rectangle from? From CNT. And I'm going to take this one, CNT, and here we're going to get a few parameters. We're going to get X and Y. Then we're going to get the width and the height, and also the angle, right this way. Let's print all of them. Print X and Y. Let's print width and height, and let's print also the angle. And let's now run this one. So we see X and Y 693, we have the X 342, we have the Y. What is this X and Y? The X and Y is the center point of the object. So if I print this, if I show this one, let's put a circle on X and Y. cv2.circle. Where do we want to draw the circle? We put the circle on EMG. The center of the circle is going to be X and Y. There is one thing that for some reason we're going to get X and Y 693 point something. When we use coordinates in Opencv, the coordinates can never be float numbers. So either the coordinate is 693 or 694. It cannot be 693 point something. So in order to avoid errors, we need to put integers so that we will have only integer numbers. Then circle, where the radius of the circle, let's make 5 pixel radius so that we can see well the circle. What is the color? Let's make it red so it's well visible. So 0 of blue, 0 of green, and 255 of red. Now finally -1 to fill the circle with the color. So we can choose the thickness of the circle. I put -1, which will fill the circle with red. And let's run this one. So I wasn't lying before, as I told you, this is the center point of the object. From this center point, we have now also the width and the height of this object, and we will have to make some operation to display this rectangle, which I will check one moment, and I will show you what we have to do to display everything. The idea is that now we are getting from each image, we're going to get the minimum rectangle that possible that we can get from the image, so that we have a few points to work with. And now I want to display the rectangle that we are getting. And so here we have the rectangle. Now I'm going to convert this into points so that we can display this one. Box equals cv2.box points. We're going to get this from, let me change something right here. From this, okay, I will put this exactly this way, okay. So this gives us a rectangle, so let's put them rect equals cv2, and then we're going to extract all the information from the rectangle this way, and then box points will take the full rectangle this way. So if now we print box, here we get these points. So now we have the points that we can draw to draw the rectangle. There is, as usual, if you see there is 489.68, points can never be a float number in Opencv, so we need to convert them into integers, and there is an easy way to do this. Box equals np, so we're going to use the numpy library. Let's import numpy. Import numpy as np, and right here box equals np.int 0 of box. If we print box now, we have only integers. And finally, let's show the points that we are getting. And we are getting exactly, we use polylines. We don't draw the polygon of the object anymore, but we draw the minimum rectangle that we can get from the polygon, because that's what we want to use to calculate the size of the object. And I'm going to put this right here, CNT. Instead of CNT, we're going to draw the box. Let's run this one. And that's what we have. Here now we have a simple box with 4 points, and we have height and we have width of this object. Now, let's show the size of this object. And to show the size of this object, at least in pixels, it's a quite simple operation, because we have already the size. Let's put some order here. This way, I'm going to draw. Here we draw all the things. Here we get the rectangle. Here we display rectangle, and here we have already the size. We have width, and we have also height of this rectangle. So we can show this right here. Let's show cv2.put text. What do we want to draw? We want to draw the text where? We want to draw the text on EMG. Now, what is the size? Not the size. Now the text. What do we want to show here? We want to show, let's say, the width. Width. And now dot format. The width is this one, width, W. Now, where do we want to put the text? We want to, let's show the text exactly on the center of the object. To show that, we have X and Y, which is the center point. So we use X and Y. And remember, when we draw X and Y, we need to convert them into integers, otherwise we'll get an error. So int X and int Y. Now font face, cv2 dot font hair shape. We have different font face. I don't really care which one we choose. Let's take the first one, font hair shape plain. Font scale, let's make this 1 of scale. Then the color, let's mix a bit of blue with a lot of green and 0 of red. Thickness 2. So I'm not sure how ugly this text will look like, but let's see. Probably we should make this a little bit bigger. Now, what you can see is that we have a long measurement of this object. We have 247 point and so on. Let's round this one only with maximum 1 number after the dot. So we're going to show this width, and then we are going to round width with only 1 number after the dot. One other thing, I wanted to increase the size, and also let's put this a bit higher than a center point. So the y goes 0 is the top, and then the more you add, the more it goes down on the screen. So if we remove some of the y, we'll place this a bit more on the top. So let's say -15. And now we have the width 247.3. Of course, this is the width in pixels. We cannot know any other width because we don't know how far the camera is from the phone. But for the moment, let's keep this size, 247.3 pixels. Let's do the same for the height. The height of this font should be around half of the size of the width. So let's see if that's correct. I'm going to copy this one for the text and put it below. And we show the height on the same way. Height, instead of showing W, which is the width, we show the height. And of course, we need to change the position. Otherwise, the text of width and height, they will be overlapping and we cannot read anything. So let's put this one. One is minus 15. Let's put the other one plus 15. And so we see width and height, which probably is not so well visible. Let's put this one a bit on the left side so that we can see this better. So let's say x minus 50 on both of them. Or even more, let's say minus 100. Of course, there are better ways to display the text. I'm just doing this to be as quickly as possible, not to make things complicated. Just the only thing is that it's readable, and that's enough. So we have height 496, width 247. Now it's the trick. Now we're going to move to the second step, and we're going to see how, using this marker, Aruco marker, we're going to calibrate. We don't need to make the calibration. This will be a reference point for the calibration of the camera. What you have to do with this one, so I have printed this one, so I'm going to put a link on the blog post where there will be a file so that you can print this one. And I will show you, after you print it, how you can work with this one. So this, by the way, is 5 centimeters by 5 centimeters. And now I have a second image. First of all, I suggest that you work with the same image right now, where I have this marker right here. So what I do is I'm going to load the second image, which is phone mark. I don't remember the title. Let me check. Phone Aruco Marker. Okay, original. Phone Aruco Marker. And this is what we get. So in this image, I'm going to use this marker, and we will see how to use this one. What we're going to do right now, by using Opencv, there is some function which can load and detect this specific marker, and this will give us some size to calibrate this one and everything. So let's do that right now. At the beginning of the code, we are going to load this one. So it doesn't really matter where. Let's load Aruco just at the beginning. Load Aruco detector. Parameters of Aruco equals cv2.aruco.detector parameters create. So this is how we load the Aruco detector. Then we need to load the dictionary also. Aruco dict equals cv2.aruco.dictionary get. And now there are different types of dictionary because we have different types of these Aruco markers. I'm not going to get into details about this one. I've printed a specific dictionary for this one, so we will be using this as a standard. CV2, and then I will make some other video where I will go more into details about Aruco, about VR and all these kind of things. For the moment, just follow along with what I am doing. cv2.aruco.dict 5x5_50, which is exactly this one that I have. So you can detect only this specific type following this dictionary. So be sure about this one, because if you print your own Aruco marker, if it doesn't follow this standard right here, you probably are not going to detect that one. So this is really important that you follow exactly what I am doing. Once we have this, we can simply now detect this on the picture. So what we do is, by using the Opencv function, okay, let me check where we can put this one. We can do this. I need to make some order. So let's load the image. First, we load all the detectors, Aruco detector and object detector. After that, we work with the image. So here we load the image. And now, even before we detect the object, we can detect the Aruco marker. And we have these corners, then underscore underscore equals cv2.aruco.detect markers. So this is the detector of Aruco. So this function right here is going to detect this one, and on corners is going to give us the boundaries, the 4 corners of this marker. Then we have here some other parameters that we get. We don't need them right now, so I'm going to put underscore for both of them. Here we need to input first, where do we want to detect this marker? We want to detect this on EMG. Second, where is the dictionary from which dictionary you want to detect this one? It's on this dictionary, Aruco dict. And now finally the parameters, which is equal to parameters, this one. And after this, to make sure that this is working correctly, let's print corners and let's run this one. Okay, I see some values. So we have 777, 318. I want to make sure that these are correctly detecting this one. So we can also draw these numbers to see that we're detecting correctly this Aruco marker. And we can do that by using the coordinates that we see here on corners and we can draw a polygon surrounding them. So cv2 let's get Aruco marker, and now let's draw polygon around the marker. cv2.polylines, where do we want to draw the polygon? On the EMG. And now the points. Here we're getting float points, but each time on Opencv we draw something, they must be always integers. So either the number is 5 or 6, it cannot be 5 point something, so only integers. So we're going to convert them int corners equals np.int0, I'm going to use the same function used before, of corners. And now we are going to draw them right here. Int corners, and then is the polygon closed? Yes, the polygon is closed. True. And okay, something is missing. So what color the polygon? Let's make this one green. 0 of blue, 255 of green, and 0 of red. Thickness, let's make this 5 pixel thick so that we can see this well. It's not working, so there is some problem with the coordinates. Print int corners. Sometimes can be a pain when they use different format. Okay, somehow I managed to make this work with just a really small adjustment. You need to remove the brackets and it will work. That's some magic right there. Now we have here the Aruco marker, which will be a reference point. Now we're going to get to the hot part of this tutorial, because it is the final part where you will finally get the trick. How can we get the size of this? So stay tuned. Each size of this marker is equal. This is a square. Is 5 centimeters and 5 centimeters. If you don't trust me, I guess that you should see this well on the camera. I don't know how well this is visible, but it's somewhere around 5 centimeters. And for all the sizes. What we're going to do, if they are all 5 centimeters, it means that the perimeter of this one is 20 centimeters. So we know that this green area right here, these green lines, have a total length of 20 centimeters. So what we do, we check how many pixels correspond to 20 centimeters. So we check the length of these green lines, which will be the boundaries of the Aruco marker. And how do we do that? Well, we do that this way. Our Aruco perimeter equals, then we have cv2.arc length. We're going to get the length of the corners, and then is this closed? The polygon is closed, so we say true. Now let's make sure that this is working correctly. So I'm going to print Aruco perimeter, and of course it's not correct, something is not working. Arc length, this is the formats on how you give here the values. I'm going to pause this one until I will find the solution for this. I guess I found out the problem. So what I see that this function is made in a way that it detects markers, plural. So if we have more markers in this corner, we're going to have multiple polygons, each one with each single marker. So it means that we need to loop through them, or if you have only one, we need to take the first. So this is a tiny mistake that is giving me this problem. So corners, usually we have many corners. The idea that this program is that it will work with just one marker, so don't put more than one. And we're going to take the first marker. So 0 for the first, and probably it should work, and finally it works. Okay, so I'm happy with this. If you have more markers, just remove one of them, because I'm making this one to be as simple as possible to understand. So let's not complicate things. We'll take the first markers, and once we have this, we have also the perimeter, which I was showing, then I'm not displaying. So perimeter, we see 590.53 and so on. So what does this mean? It means that on this image, 20 centimeters correspond to 590 pixels. And this is a great value to have. Once we have this pixel correspond to tot centimeters, we have a ratio which we can use to detect any size of any object in this picture. So this is the ratio, so it's pixel to centimeter ratio. And this is the magic trick. The most important part of this project is the pixel to cm ratio. And you, of course, if you have some different unit size in your country, you can check what's the size. I'm going to use 20 centimeters. You can check the size of this on your country, whether it's inches, or if you print this with a different size, it's not a problem. You can change this right here. Pixel to centimeters ratio is pixel cm ratio equals, we're going to divide the Aruco perimeter with what? With 20. It's 20 is centimeters in my case. And let's now print this one, print pixel cm ratio. So it means that 1 centimeter corresponds to 29.52 pixels. Now that we have this, we're going to divide the width, we're going to divide both the values of the object detected with this ratio, and we will get the size in centimeters. At least this is the idea. Now I'm going to prove this to you. So let me check right where we get the size of the objects. Here we have the width. Now here is the width in pixels and height in pixels. Now let's get width and height of the objects by applying the ratio centimeters pixel to cm. So what is the width? The width will be w width, or let's say object width, equals w divided what? Divided the ratio, pixel centimeter ratio. What about the height? Exactly the same. We divide the height, object height, is the height divided pixel centimeter ratio, and height, and now we need to display them. So the size right here will be object width, object height, and let's also add centimeters, cm. And let's now show this one. Here we have width 600.8 centimeters and height 8.4 centimeters. Is this correct? Let me check. So here is the phone. So we have the width. I'm not sure if the camera can get this one, but it's around 8 centimeters. So we will say it's correct. Probably there is a mistake of few or of some millimeters. That's normal. And also the height is 16.3. Then we have 60.8. So there is, of course, it's not 100% correct, but we are really close. You might wonder why if this is supposed to be 5 centimeters, we're going to get 4.8 and 4.7. You need to consider that there are many factors that gives us this. In our case, the most important is the distortion of the lens of the camera. So each camera has some lens distortion that changes the size of the object based on the perspective. So it's the kind of distortion that on the camera you see the objects usually are a bit rounded if you look closely. When you are aiming at some strict object, if you check and measure with the camera, there is a small round of that object, and that's why we're going to get these things. Is possible to solve this? Yes, it's possible. Of course, it will be complex. It will require some perspective transform and some calibration of the camera. That's not the goal of this course, of this lesson. Instead, now we're going to complete this one, make some change in order that we can do this in real time. So I'm going to get the frames from the camera in real time, and so we will check the size of some different objects in real time right now. Let's do that. Now you don't see me anymore because I removed the camera from the recording because I need that to detect the object in real time. If you want to download the ready source code, you can download that for the image, and also you can download this one for the video. Now I'm going to change this one in order that it will work with a video. We keep everything for the parameters the same, we only need to change this one. So instead of loading an image, here we're going to load cap object. It means that we're loading the camera. Cap equals cv2 dot video capture, and here we define the camera 0. So if you have multiple webcams, you can change with 1, 2, and so on. Then we can get the frame So we can get the image in real time from this one, cap.read. And let me show what is happening right now. So if I run this one, it will work exactly the same. Okay, now I'm running the old one. Let's run this one. It will be exactly the same as before. Instead of loading the image from a file, we're loading a single image from the camera. So now it takes some time to load the camera, but here we have it. And here we see we have the objects loaded in real time. Now, more interesting will be, of course, to get this in real time. So now we loaded only one image. What is the secret to load multiple images? Well, the secret will be to put everything in a loop while true. So instead of getting only one image, we're going to get one image after the other, no stop. So we're going to work with everything that is right here inside the loop. There is some change needed here. cv2.waitKey 0 is freezing the frame, so it's keeping the frame on hold. We need to change this one so that it will work in real time. cv2.waitKey 1 will wait only 1 millisecond and then move to the next frame. If the key is equal to 27, we add this one so that we can break the loop. 27 is the S key on the keyboard, so if we press S, we can quit the program. We finally release the camera, cap.release, and then cv2.destroy all windows. And we can now run this one. Another thing that I wanted to make is to make this more higher quality, is to put this in HD size. So by default, Opencv uses 640 by 480, which is a low resolution for the camera. Instead, I'm going to say cv2.cap prop frame width. We're going to give 1280 of width, and cap.set cv2.cap height, and we're going to give 720 of height. Not all cameras will support this resolution, but most of them will. So if you're getting some error, just remove these two lines, and I'm going to run this one. And now we should see the frame much bigger with higher resolution, and we should be able to detect the size of the objects in real time. It's a bit slow, I don't know why, with Opencv. In general, some version of Python with Opencv, I noticed that it's quite slow to load the camera. So you might face the same issue, but it's not a problem as long as it's loading this one. Okay, we have, now it's in real time, so you can see, okay. It's in real time and it's interesting. So when I put my hand on it, we got some error. Probably if we don't have objects, we're going to get the error. On line 30, we got, okay, we're getting the perimeter of Aruco even if there is no marker detected. So if we try to get the perimeter and there is no marker detected, we're going to get an error. So the idea is only if we have the corners detected, so if corners, only in this case we're going to check everything. We check the object, we check the marker, and so on. Otherwise, we don't do that. So everything, everything is up to the Aruco marker. If we have the Aruco marker, we check for everything. If we don't have that, we're going to skip that one. Okay, now again, here it's working in real time. So we have the size of the phone in real time, and I can prove that it's in real time. Here you can see my hand. Now the size here, it says 600.8 centimeter. If we check width, okay, sometimes it's the width is this one right now. It's 16 point something, so it's not precise 100%, but it's close, probably with around 5% of error. So the margin is 5%. What is the nice thing about this method? That it doesn't matter how far the camera is, even if it's closer, this marker is going to give a reference point for the size. And we can put also multiple objects. We have 2.2 centimeters and 6.2. Let me check. 2.2, yeah, we're there, and 6 point, probably it's around 6 centimeters, 6.1. So it's quite precise. So no matter the distance of the camera, here is this one. I hope that you enjoyed this tutorial, that you got useful information from this one. I'm happy about the result because it looks quite precise despite the simplicity of the code and the program itself. If you want to learn more about more advanced solutions, I recommend to check my website pysource.com.